Good day. I'm David Wall, a student at Liberty University's School of Education. This presentation is an adaptation of my research project entitled Exceptions to the Redundancy Principle. The redundancy principle states that instruction delivered via narration and images is more effective than instruction delivered via narration, images, and text, due to the load that the latter places on learners' working memory, resulting in them having to process more information through the visual channel alone. Boundary conditions exist in which the redundancy principle does not apply, as in self-paced learning or highly technical and verbose content. Another example of a boundary condition is instruction for ESL or English as a Second Language learners. Research indicates that the redundancy principle is rendered useless for these types of learners. This paper goes further by suggesting that a reverse redundancy principle may be observed in second language instruction, where learning is supported and enhanced by the use of redundant instructional materials. This suggestion is supported by research showing the same, along with research demonstrating a similar effect in a virtual reality classroom, simulating typical classroom environment. Finally, this presentation points to subject matter content, learner characteristics, and learning environment as the arbiters of what delivery method instructional designers should take, asserting that multimedia principles, including redundancy, are entirely dependent on learning objectives. Multimedia learning refers to instruction that incorporates different forms of media simultaneously to deliver instructional content. It may include visuals, animations or videos, lectures or recorded narration, or even interactive games. It's become a fixture in many industries and institutions as an effective way to deliver training, whether in a traditional classroom environment, in an online college course, or in a company-sponsored computer-based training course. A reason for this might be due to the way learners process information. According to the cognitive theory of multimedia learning, multimedia instruction makes use of different information processing channels, including the auditory and visual channels, to avoid overloading learners' working memory and thereby allow them more effective processing and encoding of new information, according to Liu et al. 2018. This allows educators and instructional designers to design training content that leads to more meaningful learning experiences, since they are designed with consideration for how the human mind works and take advantage of key principles associated with multimedia learning, according to Keshavares et al. 2022. This presentation will be concerned with these principles and how they interact with different types of content. In the case of one in particular, the redundancy principle, content has an overwhelming impact on its applicability. In simple terms, the redundancy principle states that content such as text should be delivered via only one channel, such as narration, to avoid cognitive overload. The use of both channels to deliver the same information, therefore, is counterproductive. There is significant research and literature available on the principles of multimedia learning in general and the redundancy principle in particular, Keshavares et al. 2022. Selected samples of this literature will be used to support the thesis that the redundancy principle does not hold in the instruction of different types of content, and in the case of language learning, a reverse redundancy principle is demonstrated. In discussing the redundancy principle, the modality principles must also be considered since they are closely linked. According to Clark and Meyer, 2016, the modality principle has received the most attention of all the principles in terms of research and study. In multimedia instruction, where visuals are presented alongside words, significant learning gains occur when the words are delivered audibly rather than in the form of written text, since the use of the visual channel to process images as well as written words can strain the working memory of learners. Again, Clark and Meyer, 2016. Referring back to the cognitive theory of multimedia learning, learners have a finite amount of working memory in either channel, and instructional designers would be better served leveraging this cognitive ability in designing instruction. As Notel et al. 2022 points out, it is easier for learners to process a voice and image simultaneously than to have to read text and view an image. This principle might spark interest in many educators to take full advantage of both channels of information, designing myriad audio and visual resources to aid students in processing new knowledge. If a little is worth a good deal, more is worth more. If a lecture accompanied by slides and video improves upon a lecture alone, then certainly handouts and accompanying reading during the lecture would better equip students for learning. Perhaps not, however, as the modality principle does not necessarily stand alone. Similar to the modality principle, the redundancy principle holds that presenting words in spoken and written form alongside images results either in learners paying less attention to images and attending to the written text, or in learners becoming overwhelmed due to excessive information being presented in the visual channel, reducing the ability of their working memory to process the new information. Clark and Meyer, 2016. Presenting words in spoken and written form, then, is considered redundant. Rather than reinforce learning, presenting too much information in both auditory and visual channels simultaneously is believed to inhibit learning, causing excessive cognitive load for learners and preventing excessive processing of new information. And so, as seen in the previous example, redundant information actually can challenge learners by presenting too much information rather than just enough. This overwhelms the cognitive load, causing too much information, which muddles up the process, preventing processing of new information. Very similar to trying to pour a gallon of water into a quart-sized funnel. It simply will not fit, thereby frustrating learners and resulting in no new information being processed. One study that demonstrates this, and it's presented here on the slide, presented computer programming instruction to two different groups of first-year college students over a 5-week period. The study was conducted by Chia and Leong, 2019. One group of students received audio, visual, and written or on-screen instruction, while the other group received only audio and visual instruction. In the case of the first group, the on-screen text mirrored the audio content. After testing, it was observed that the second group, Group 2 here in the visual, who received instruction without the accompanying on-screen text or the redundant elements, actually outperformed the first group, indicating that the redundancy principle was supported by the study. With that being said, unlike other multimedia principles, the redundancy principle is not definitively supported by available research. Seekin and Task in 2022, in their survey of literature regarding redundancy, found that roughly half the studies showed no connection between application of the redundancy principle and enhancement of learning. This might indicate a need for further study on the topic, as they point out, or it may point to conditions in which the redundancy principle is not apropos, which leads into what this presentation will be primarily concerned with. That there are conditions or situations in which the redundancy principle may be rendered ineffective is pointed out by Clark and Meyer, 2016, in their discussion of the principle. These situations where learning might be benefited rather than inhibited by redundant on-screen text, or perhaps just not affected by redundant on-screen materials. They are referred to as boundary conditions. Examples of these boundary conditions, as you can see on the visual example here, include instructional content with no additional graphics, i.e., no competing information to be processed in the visual channel. So what you see on the screen here, we have text mirroring key content from my lecture, and we have a a non-interactive graphic on the screen, really just to provide aesthetic value. In this case, the visual, the image of the puzzle piece standing out and not really fitting in, doesn't compete for a lot of your working memory. Instead, you are free to concentrate on the words on the screen. Therefore, we are not violating the redundancy principle, even though what is on the screen, text-wise, is mirroring some of my presentation. Another example would be slow-paced or learner-paced presentations, narrations which may contain technical or unfamiliar words to the students, and redundant text that is shorter than the accompanying narration, as in the case of keywords or phrases. All this pointed out by Clark and Meyer in 2016. 4 examples there of boundary conditions, and now we'll just briefly go over them and look at a more clear-cut illustration. In the first example, as in the case of the slide itself, the absence of accompanying visuals means that incorporating on-screen text satisfies the modality principle, since information is presented visually as well as audibly. In the example here on the screen, we have a projection screen with the text. The term head on a swivel refers to situational awareness. And then below, the illustration demonstrates a narration accompanying this visual. The term head on a swivel refers to situational awareness. In this case, even though the visual representation of those words mirrors the narration, they are being processed by both the audio and visual channels. There's no other visuals or graphics competing for the attention of the learner, meaning we're not violating the redundant principle as much, and we are in fact following the modality principle. In the second example, which might be termed self-paced instruction, the redundant on-screen text actually provides referral material, or material that the student is able to refer back to in the case of studying or preparing for a course. This reference material that allows the learner to refer back to it can lead to what Liu et al. 2019 refers to as a reverse modality effect, which has been shown to lead to a higher learner performance. And in the third and fourth examples, which are closely related to the thesis of this presentation, content is of a complexity that redundant material is actually complementary to instruction rather than detrimental. Lee and Meyer in 2018 assert that evidence indicates a correlating decline in the applicability of the modality and redundancy principles as the length and complexity of a text increases. In other words, the longer and more complex a subject matter is, the less experienced a student or the learners are in this particular subject matter, then the more redundant materials would actually help or be shown to increase learning. That's what this presentation will be about. This would indicate that certain content areas, as well as, again, certain learner categories, such as inexperienced learners, would benefit from the incorporation of redundant materials in the design of instruction. A key difference between examples 3 and 4 is the nature of the redundant materials. Again, in example 3, you have mirrored narration and on-screen text, whereas example 4 looked at more short phrases or keywords. Whether one or the other is more beneficial is open for debate. However, along with other assumptions of this presentation, content and learner characteristics are going to inform this decision for instructional designers. Another boundary condition which may be proposed is the environment in which instruction is delivered. In a study conducted by Liu et al. 2021, 2 versions of instruction, one with redundant elements and one without, were delivered in 2 different learning environments. This resulted in 4 distinct samples for review. The first environment was a relatively controlled computer lab, which Liu et al. Postulated as representative of the environment found in most studies. specifically multimedia instructional studies. The second environment, however, was created with the use of virtual reality headsets in order to simulate a real school classroom with environmental distractions such as other students talking, perhaps the speaker looking away, turning away, white noise from the hallway or outside the window, just different environmental white noise and typical real world interactions that can distract from instructional delivery. The question Liu et al. 2021 sought to answer was whether environment had an effect on the applicability of the redundancy principle. Results actually supported the redundancy principle in the controlled computer lab environment. In other words, in the environment that the researchers postulated as representing the typical study environment with controlled stimuli. The students receiving instruction without redundant elements outperformed their counterparts. However, what was interesting about this study is that the opposite was found to be true in the simulated real-world classroom, with students receiving redundant instruction demonstrating more comprehension and retention than their counterparts who did not receive redundant instruction. So this supported the hypothesis of Liu et al. That redundant material compensated for what was lost by the learners due to the influence of outside stimuli. So again, this illustrates the flexibility of the redundancy principle in regards to content, environment, learners, etc. So the key takeaways from this consideration of boundary conditions and the nature of the redundancy principle's applicability is that there appears to be a considerable degree of dependence on what is being taught, as you see on the screen here. Designing instruction is dependent on what is being taught. Ramsden 2022 points out what works for one group of learners or one type of content will not necessarily apply in every situation, no matter the similarities. Educators and instructional designers must take great care in their analysis and design to consider the needs of an organization, of the learners, and develop specific objectives that are supported by the most appropriate form of instructional delivery. These takeaways can be expounded in our next section. Lee and Owens, 2004, they make an assertion that the medium is not the message. In terms of instructional design, the most importance lies in what learners need to know or be able to do at the end of a training course. That is the entire essence of training, is to impact performance, impact the knowledge, skills, attitudes, and abilities of our learners. These instructional priorities should be determined in the analysis phase of design well before any consideration of delivery is addressed. Instructional designers, alongside stakeholders and other interested parties in terms of instruction, must take great care to identify content with the outcome in mind and approach training development from that same perspective. Everything used in terms of delivery and content must be shown to lead to the end determined by the objectives and priorities. So in the case of multimedia design and use, it can be tempting to fill a training course with the most captivating and informative material, graphics, videos, animations, and layout imaginable, and yet miss the mark of performance improvement. And as the second bullet point here illustrates, the most engaging multimedia experience is completely useless if it fails to deliver learning according to the objectives of the instructional design plan. So again, instructional designers, educators, our purpose is not to entertain. Our purpose is to educate, to train, and to influence performance. Ramsden 2022 points out several factors that need to be addressed in order to develop effective instruction, and that includes learners' needs, the subject areas, the content, and learning context, and how that should be considered in designing multimedia content. Instruction should be customized to fit the target learner and their needs. So as the illustration in the slide here points out, objectives will lead to the content, And then objectives and content together will inform delivery. How will this content be provided to the learner? One example of this idea of content and objectives driving delivery comes from the field of public safety, and it would be firearms instruction. So, if the goal of the instruction is for learners to know the parts of a firearm, instruction could include narration, keywords and terms displayed on screen, as you see in the visual here, and perhaps images and interactive animations depicting parts of a firearm or handgun. On the other hand, if the goal of instruction is for learners to be able to effectively operate a firearm, no amount of multimedia or principles or interactivity would replace hands-on practical instruction. Again, the objective determines the content determines the delivery. Liu et al. 2019 describe a study involving the use of the modality principle in a physical learning environment, similar to our previous example of firearms. In this case, the physical learning environment involved working with plants. Students were presented with either written text or spoken text in conjunction with realistic, interactive, visual representations of various plants. In keeping with the modality principle, the students with spoken text displayed higher transfer of learning initially, since they were using both auditory and visual channels to process the new information. In contrast, the students who received written text had to interact visually with both the text and the plant images, resulting in a competition for their attention and a strain on their immediate working memory. Despite the initial transfer of learning, however, there was no significant difference in retention and comprehension between students receiving spoken versus written text following the class. This led Liu et al. To assert the importance of considering, once again, instructional objectives prior to determining what delivery method to use. It is interesting that while this study was not directly concerned with the redundancy principle, it was shown that redundancy, or the use of written text along with visual representation of plants, even though it might not have been shown to benefit instruction, it did not significantly impact students' retention or comprehension negatively either. Instead, both the modality and redundancy principles were shown to have little applicability in this study, again highlighting the importance of learning objectives and content for applying multimedia principles. This leads to another area in which the modality and redundancy principles don't behave as one might think they should, and that's instructing ESL, or English as a Second Language students. Lee and Meyer, 2018, refer to the substantial body of research in multimedia instructional principles, and they point out that much of that research focuses on learning delivered in the learner's native tongue. As indicated above, instruction in a learner's primary language redundant text has been shown to increase the load of information being processed via the visual channel, thereby potentially inhibiting the learning process, the redundancy principle. For non-native speakers, however, the use of redundant text could actually lessen the cognitive load for learners who have to work harder to decode unfamiliar words and concepts, according to Lee and Meyer, 2018. This assertion was echoed by Liu et al. 2018 in pointing out that the often underdeveloped reading and listening skills of non-native speakers can render redundant material beneficial in the learning process. Both Lee and Meyer and Liu assert that the modality and redundancy principles do not apply to ESL learners. In most of these studies, they were shown to have no impact whatsoever. And both of these authors point to studies which definitively demonstrate this, but they disagree on one key point. Lee and Meyer make the theoretical inference that the use of redundant materials can support the learning of ESL students, while Liu rejects this notion, pointing to a lack of conclusive empirical research. What is apparent is that instruction delivered to ESL learners presents yet another boundary condition, as those described above. And although this relates very closely to examples 3 and 4, which were discussed earlier in terms of complex or new materials. And that's what we'll be looking at moving forward. So as we consider the intersection of language and the redundancy principle, we need to make a distinction before we move forward between what Liu 2023 calls content knowledge learning and language learning. Content knowledge learning refers to instruction that uses language to teach students about something outside of that language. So, for example, a specific content area, such as computer programming or plants or firearms from our earlier examples. The instruction of non-native speakers and ESL learners previously described all fall within the confines of content knowledge learning. Language learning, on the other hand, involves instruction that teaches students how to speak in a language other than their own. While it has not been definitively shown that redundant elements of instruction support the learning of ESL learners in content knowledge, can the same be said of second language instruction? It has already been pointed out that the inclusion of redundant instructional material assists learners in decoding complex words, phrases, new terminology outside of their native language, thereby decreasing the cognitive load, according to Lee and Meyer, and better enabling them to process and encode new information. Ramson, 2022, makes a similar point in directly applying that same principle to second language instruction, in which the introduction of new words and concepts places tremendous load on learners. Not only are they learning new concepts and words and phrases, but they're having to translate in their head and work everything out in order to interpret this new knowledge. They're not simply working with knowledge itself. Now they have to worry about how they're learning this new knowledge. It's very meta in that way. Notel et al. 2022 points out that even in content-specific instruction, the use of key words displayed along with images and narration has been shown to support learning and reduce cognitive load for learners. If that is the case, and studies can be shown that it is, how much more effective would the use of such redundant materials prove to be if words themselves were the topic of instruction? Demir et al. 2022 designed a study to test this very question, in which university students were delivered augmented reality second language instruction. These augmented reality flashcards resembled what you see on screen here, where you have images, text, and speech, or some combination thereof. So we have one augmented reality flashcard with an image, a text, and then the actual audio or narration of the word itself. In the case of the other example, we have just the picture and an audio narration of the word. So Demir used these augmented reality flashcards containing two versions of the same information, as you can see on the screen here, to test university students and determine, based on a pre-test and post-test, if there was an impact on retention and comprehension. Demir observed that not only was the modality principle applicable in this direct example of second language instruction, students learned better with information transmitted through both channels, but the students receiving redundant instructional materials outperformed the other two sets. In a similar study, Ramson 2022 again examined second language instruction directly with two separate groups of students, one receiving animation plus narration, and the other receiving animation, narration, and on-screen texts. And again, in post-study testing, post-instructional testing, measurements revealed that the students who received the redundant elements, again, not only were they not affected negatively by the redundant elements, they were actually benefited. Their learning was enhanced by the redundant elements, indicating this reverse redundancy principle. So it can be definitively said at this point that certainly there needs to be considerably more study into second language instruction and its intersection with the principles of multimedia instruction and learning. But in examining the studies and examples in this presentation, a pattern emerges. First, it is acknowledged that there are conditions in which the redundancy principle is not applicable. These are those boundary conditions that we discussed early on. They've been shown to include presentations whose content is not easily decipherable by learners, or when new and complex subject matter is delivered, as in the case of second language learning, learning a new language. Lastly, specific studies have been cited which demonstrate that not only is the redundancy principle not applicable in instances of second language instruction, but learning is instead enhanced by redundant elements, which lessen rather than compound or increase the cognitive load experienced by learners. This reverse redundancy principle may be used to guide educators and instructional designers in creating more effective learning experiences. So the immediate application of this to a professional setting is it highlights the importance of determining what is to be learned, determining the characteristics of the learner, the context of performance, and the environment in which learning and performance will take place. This will inform what is to be taught and how it is to be taught. It can be very easy to lose sight of the forest for the trees with instructional design. The advent of new and exciting technology, new pedagogies, methodologies, they can lead to instruction for the sake of instruction. This must be guarded against at all costs. Understanding the principles of multimedia instruction, how they relate to one another, and ultimately how they depend on objectives and learners will better prepare instructional designers to design and develop meaningful learning experiences, leading to performance improvement for their students and their organizations. So the redundancy principle is certainly a factor in instructional design. It cannot be said that there aren't content areas in which redundancy harms rather than helps students' learning. In the same way, however, there's considerable research indicating that there are instances where redundancy has no effect. Clark and Meyer make this point in 2018 when they point out that boundary conditions, of which several have been discussed and expounded upon in this presentation, affect whether or not redundant materials impact learning. Environment, context, learner characteristics, content all play a part in determining the best course of delivery to take in designing effective instructional interventions. And the proficient instructional designer will take all of these into account in any production design. Two particularly pertinent examples of boundary conditions are the instruction of ESL learners and second language instruction. It has been shown that, like other boundary conditions described, the redundancy principle bears no weight in these two types of instruction. And in the case of second language instruction, learning new languages, redundancy incorporated into the instruction was shown to support and enhance learning. Demir et al., Ramson, both 2022, demonstrated this in their studies. A similar result was seen regarding disruptive environmental stimuli, where redundant instructional material replaced what students lost due to classroom white noise. Again, that was pointed out by Liu et al. 2021. This would contribute validity to the results of the former studies by showing the positive or negative effect of redundancy is dependent on several different factors. Taken as a whole, this data indicates that not only are there conditions in which the redundancy principle has no effect, but there are conditions in which a reverse redundancy principle may be observed, particularly in the field of language instruction. Nevertheless, more study is needed to resolve the inconclusive nature of much research conducting the redundancy principle in different learning contexts.